Hello everyone, welcome to Computer Science and IT Gate Coaching. Don't forget to subscribe my channel and press the bell icon to get the instant notification of my free lecture. So this is about me. I am a computer science gate faculty having more than 5 plus of teaching experience, mentored more than 50,000 students, taught in different coaching institute all over India. Okay, it's like the Gate Academy, even qualified multiple times Gate, and even I have given the coaching in many government colleges as well as in many private colleges. Like in SRM Chennai, I have given coaching. CAT Bhubaneswar, I have given. BC Bhagalpur, Jorhat College of Engineering, Guwahati University, Dibrugarh University, Government College of Engineering and Technology, Jammu, Ramgarh Engineering College. Okay, these are the colleges where I have went and I have given the coaching. So the language, context-free language, the machine that accept the context-free language is called as Pushdown automata. Okay. So to accept a context free language, we need a machine called Pushdown automata. We need a machine called Pushdown. That is PDA. Small form is PDA. Bracket you can write as PDA. So to accept a context-free language, we need a machine called Pushdown automata. Clear? So PDA is made by adding. So we write the second step. PDA is made by adding an infinite memory that is stacked to FA. FA plus stack is your PDA. If you are done with the writing, then please let me know. So PDA is FA plus stack, and stack is your infinite memory. Why I am saying it is an infinite memory? Because the size is not fixed, it is unbounded. Size is not fixed, it is unbounded. Okay. Here size of stack is not fixed, it is unbounded. That's why we call here stack as a infinite memory. That's why here we call stack as a infinite. Memory. Okay. So there will be one control unit like this there, and input will be here like this. Input file is your input file. Then here you will get the stack. Okay, this is the stack, and I am showing at below it is open. Okay, you can show in the beginning only. Let me show in the beginning only, so that no confusion will arise. This is the stack. Like this PDA will look like. Okay, there. So control unit will see the input as well as the stack to decide the transition. Here the control unit means, in control unit the states will be present. So the state will see the input that is present in the input file and also the symbols that is present in the stack. Then only it will decide the transition, that where to go. So here we don't require only the input, here we require also the stack symbol. Okay, so by seeing the stack symbol, it will decide where to go. So both state with input symbol as well as the stack symbol is required to give a transition. यहाँ पे हमें तीनों चीज़ लगेगा, स्टेट्स लगेंगे, इनपुट सिंबल भी लगेगा और स्टैक भी लगेगा. अब कैसे काम करता है वो मैं अब लिखूंगा. चलिए दूसरे स्लाइड में जाते हैं हम. So right, next point, that point number was 3. Each move of the control unit, each move of the control unit reads a symbol from the input file, reads the symbol from the input file, while at the same time changing the content of the stack, changing the content of the stack through the usual stack operation, Okay, so example, that point 3 is each move of a control unit reads a symbol from the input file. It will read a symbol from the input file. At the same time, changing the content of the stack. It will always change the content of the stack to the usual stack operation. Usual stack operation is push or pop. It will change the top of the stack. Either means it will replace with same symbol or it will replace with epsilon, means it will pop it. So push pop operation. So it is always at the same time. It will change the content of the stack through the usual stack operation. Is it done? So point 4. So each move of all these points are very important. Each move, because if your basic are not strong, we will face the difficulties while constructing a DFA. Sorry, not DFA, pushdown automata. So similar like FA, first we have seen the theory part, then we have constructed. Here also, first we will see the theory part, which is pushdown automata, how different kinds of, then we will construct the pushdown automata. Okay. So each move of the control unit, and it is also a very interesting topic as the DFA. Okay, we have to construct a machine here. Each move of the control unit is determined by the current input symbol as well as by the symbol currently on top of the stack. The result of the move is a sum state. The move is the sum state of the control unit and a change in the top of the stack. So each move of the control unit is determined by the current input symbol. Each move of a control unit is determined by the current input symbol as well as by the symbol currently on the top of the stack. Symbol that is currently on the top of the stack. So that two things is going to decide the move of the control unit, means move of the state. The result of the move is a sum state. It will go to some state, either to same state or some new state of the control unit, and it will always change the top of the state. always change the top of the stack. This is very important. So each movable control unit is determined by the current symbol and the current symbol on the input and the current symbol on the top of the stack, and it will go to the same state or some new state, and it will always change the top of the stack. Okay, it will always change the top of the stack. Clear? So this is the basic of push down automata, how it's work. I have taught you everything. The fundamental I have taught. Now we will see types of push down automata. Is it done? Can I go to next slide? So there are two types of push down automata. One is deterministic push down automata, another is non-deterministic push down automata. So types of push down. Is it done now? Types of push down automata. We're done with the writing. One is deterministic push down automata. Deterministic push down automata. Another is non-deterministic push down automata. Another is non-deterministic push down automata. There is non-deterministic push down. So first we are going to see deterministic push down automata. So in place of automata you can even write acceptor also. So now going to deterministic push down automata. DP deterministic push down automata. PDA deterministic push down, ND non-deterministic push down automata. Okay? So a deterministic push down automata is defined by the shape tuple. Shape tuples means 7 tuple. Meaning consisting of 7 parts. Consisting of 7 parts or elements. Shape tuple means consisting of 7 parts or element. N equal to Q sigma tau delta Q0 Z is F. Okay. Where Q is a finite set of internal states of the control unit. Okay. Sigma is the input alphabet. Tau is a stack alphabet. Here tau is stack alphabet, means here they are defined that these only symbols that are present in tau you can use in stack. So tau is the finite set of symbols. You can't use other symbols except the symbols that are present in tau, that only you can insert in the stack. Is a finite set of symbols called the stack alphabet. Is it clear? So Q0 is the initial state. Q0 belongs to Q, is the initial state. The initial state of the control unit. The control unit is the initial state of the control unit. State belongs to tau. Is the stack start symbol. It is the stack start symbol, or you can say that bottom of the stack. Okay, stack start symbol. It is always going to be present this is a stack, then Z is always going to here. The stack start symbol. Okay, Z is your stack start symbol. Then if is set of all is a set of final state, is the set of final state, is a set of final state. Now delta, the very important thing in the deterministic Pushdown. Here one state by getting some input or by only getting epsilon, here epsilon move is even possible, then by seeing the top of the stack it can go to one state and it can replace the top of the stack with n number of stack symbol. Okay, the transition function. Here one state by getting the, by seeing the stack, by seeing the input from the tape, by seeing the input or by only seeing the epsilon. The lambda, you know that it is epsilon also. Sometimes lambda they use, sometimes pi they use, sometimes they will use epsilon. One state by getting some input or by only getting epsilon, by seeing the top of the stack it will go to one state, and it will replace the top of the stack with some string or by epsilon, because it's a tau star, so it will replace the stack symbol with some stack symbol. Is it clear? So delta of deterministic Pushdown automata we have seen as q cross epsilon union tau, not tau, that sigma union epsilon into tau, this is tau. It will goes to one state and it will replace the stack symbol. This we have seen that one state by getting some input alphabet, by seeing the top stack it will go to only one state and it will replace the stack, top of the stack with some stack symbol. Okay, that is stack string, means that stack is having, this is the stack alphabet, and with that it is going to get any combination of that, with that it is going to replace. Okay, so you should write. After that, two more points is there. For every q belongs to q, A belongs to sigma union epsilon and B belongs to tau. Okay, so q belongs to capital Q, input alphabet belongs to either q or epsilon, and B belongs to tau. Okay, so it must satisfy, the given, so it must satisfy the given two conditions. So it must satisfy the given two condition. Okay, so it's going to satisfy the two condition. Okay, one is delta q a b contain contains at most one element, most one element. So it is saying that one state by getting some input alphabet and by seeing the top of the stack, it contains at most one element. That means at most one move is possible. At most one move, you write move, then it will be more easy to understood. Contains at most one move. Okay, it means delta on getting q on b can be empty also, or maximum one move. It can go to some state and it will do something. Okay, see, at most one move means here for every state, for every input alphabet, it is not required to give the transition. If you want, you can give. If you don't want, you can leave it. Am I clear? Second point is if delta q epsilon b is not empty, then epsilon q cb must be empty for every c belongs to sigma. Here what I mean that if you have given a transition, if the state have given a null transition on some top of the stack B, it's not empty, means you have given some transition, means Q by getting epsilon and by seeing the top of the stack it is replacing with B. Let us assume it is replacing with B, and it went to some state. Okay, then Q, then this Q on getting some input, C can be any input, by seeing the same top of the stack, that is B, you can't give the transition. This is not allowed. If one state by getting epsilon and the top of the stack is some symbol, let us assume here B, then for same state and for same top of the stack you can't give for other transition. Here same state and same top of the stack you can't give any other transition. It is very important. It is very important. The student get confused between this, and this is not explained in many of the classes. I don't think that in colleges and other faculties used to teach this. So it's saying that one state, if you have given a null transition when the top of the stack is B, then that state on the same top of the stack you can't give any other transition. But if I will change the top of the stack like C, then I can let D, then I can give. This is allowed. This is valid. It is saying that if one state by getting some top of the top of the stack is B, okay, and if you have given a null transition is not empty, then for same state and for same top of the stack you can't give any transition for any other input alphabet. But if I'll change the top of the stack, if I'll change here top of the stack, I change to D, then you can give the transition. Okay, am I clear? This is very important. Now go to the, so I will write whatever I have told. Now I will write. So first point, what first point is saying? The first of this condition, this condition simply requires that for any given input symbol, and any stack top, at most one move can be made. So this is the explanation of the first point. The first of these conditions simply requires that for any given input symbol and for any stack top, at most one move can be moved. At most one move can be made. Maximum one move can be made. The second condition is that when a null move is possible, for some configuration, then no input consuming alternative is available. Then no input consuming alternative is okay. Then no input consuming alternative is. So if you are given a null transition for some state and for some top of the stack, then you can't give the any other input transition for same state and for same top of the stack. You can change the top of the stack, then you can give the transition. So now write a language L is said to be a deterministic. A language is said to be a deterministic context free language if and only if there exists a deterministic pushdown automata aim such that L is equal to language generated by that deterministic pushdown automata. It means what I am able to say here, what I want to try to say here, that if for a language L, if you will give a deterministic pushdown automata, then that language is deterministic context free language. That I've told you that you can even say that whether a context free language is deterministic context free language or non-deterministic context. If for a language, if you can give a deterministic context free language, then that language is deterministic context free language. If for a language, if you are able to give a non-deterministic, then it is a non-deterministic context free. Am I clear? Give a note and then write. The result of delta is pair qx, where q is the state of the control unit, and x is a string that is put on the top of the stack, in place of the single symbol here. Okay, what I am saying here, the result of delta is a pair qx. The result of the delta that you are going to get is qx one state and x, where q is the state of the control unit, and x is a string that is put on the top of the stack in place of the single symbol there before. So if the stack is having some symbol, it will get replaced. Let us, it is having some symbol, let us assume it is having b, then it will get replaced by x. And x is a string that is put on the top of the stack in place of this. You write in place of this. Okay, in place of the single symbol there before. Is it clear? Only single symbol at a time, we can replace only single symbol at a time. All these points are very important, because when we will do the problems, all these concepts are required. If you are having a b, it will replace with x. Fine. So going to the next point. Now delta is defined in such a way that so that it needs a stack symbol. No move is possible if the stack is empty. No move is possible if the stack is empty. So delta is defined in such a way, because you know that delta is saying that q cross sigma union epsilon cross tau. So delta is defined in such a way that we also require input symbol. Here it is the top of the stack. It is the top of stack. Okay, so delta is defined in such a way that it need a stack symbol. Okay, it need a stack symbol. No move is possible if the stack is empty. If the stack is empty, no move is possible. Okay, this is very important. If the stack is empty, no move you will able to do. Okay, no move you will able to do. Are you done with the writing? So now third point, it's also very important. The transition. The transition SBX goes to T. Say T X Z0. Okay. Means that if the PDA is in state S and symbol, what this transition means, SBX, if they have given, first let me explain, then I will write SBX goes to T X Z0. What does this means? It means S is a some state. By getting B and by seeing the top of the stack X, it replace X, X with Z0 X in that order. First it will replace Z0, means push Z0, then it will push X, and then it will move to state T. Then S will move to the state T. So X will get replaced by Z0, then X. Is it clear? First Z0, then X. In that order, from right hand side, this string will get pushed. Am I clear? Clear hai kya? Then the string S will go to the state S will go to Z. Is it clear? Please let me know. Clear hai kya? They're saying yes. Fine. So if the PDA is in state S and the symbol on the top of the stack and a symbol on the top of the stack is X, then it can read B from the input, it can read B from the input and move to state T after popping the top of the stack, and pushing the symbol Z0 and X in that order on the stack. Now here in PDA we are having two types of acceptance. One is if string will reach to the final state, it will get accepted. Another also, if when a string get exhausted, it should reach to the stack should also be empty. What I mean, here we are having two types of acceptance. One is acceptance by empty stack, another is acceptance by empty stack, another is acceptance by final state. Don't write this, I will give you the note now. So in empty stack, what happened when a string got exhausted, means when a string get finished, when a string get finished or exhausted means finish, then your your stack will be empty, then stack will be empty. Then we can say that your string is accepted. You know that when stack is empty, you will not able to give any transition. Okay, so that's why here we are having a two types of acceptance. One is acceptance of empty stack. So when a string get finished or exhausted, your stack should be empty. Okay, or you can directly reach to the final state. So there are two types of acceptance in case of push down automata. So PDA can be, now right, PDA can be, all these things are very important. Okay, PDA can be accepted by two ways. PDA can be accepted by two ways. One is acceptance by final state. One is acceptance by final state. One is acceptance by final state. Another is acceptance by empty stack. So one is acceptance by final state, you will reach to the final state. Another is acceptance by empty stack. You will, what you will do, you will empty the stack. Okay, so now write the, I will write the definition of both the acceptance. Okay, so what it means. Empty stack, first let me know whether you are done with that. So now write empty stack accepting yes, empty stack accepting P are the empty stack accepting PDAs are the PDAs for which a given input is accepted, if on a given input, if on a given input string, when the input exhausts, the stack should be empty. The stack should be, okay, stack should be empty. Stack accepting PDAs are the PDAs for which a given input is accepted. If on a given input string, when the input exhausts, the stack should be empty. If you're done with the writing, then please let me know. Similarly, a final state accepting PDA is a PDA. Similarly, a final state accepting PDA is a PDA for which a given input is accepted, if on a given input string, when the input exhausts, PDA, PDA should be in one of the PDA should be in one of the final state. Okay. Similarly, a final state accepting PDA is a PDA for which a given input is accepted, if one of the given input is string, then the input exhaust, the PDA should be in one of the final state. Okay, so when the input is finished, then the PDA should be in one of the final state. वो एक final state में होना चाहिए. Clear है? Is it clear? तो जब भी एक स्ट्रिंग खत्म हो जाए, ठीक है, अगर वो फाइनल स्टेट में पहुंच गया है तो इसका मतलब क्या, वो स्ट्रिंग एक्सेप्टेड है. लेकिन इसका मतलब ये नहीं है दैट it should only reach to the final state when string is finished. It can even encounter the final state while traversing. तो अब देखिए, इसका मतलब ये नहीं है कि सिर्फ जब स्ट्रिंग खत्म होगा तभी सिर्फ वो फाइनल स्टेट पर जाएगा. वो उससे पहले भी देख सकता है, मतलब फाइनल स्टेट पर जा सकता है, लेकिन रुकेगा जब स्ट्रिंग खत्म होगा, तो रुकना उसे फाइनल स्टेट में ही चाहिए. ठीक है, क्लियर है? So you write this also. It does not mean while scanning the entire string, we will not encounter the final state or accepting state. It may happen that before input get exhausted, we can encounter n number of times final state. Okay, so I have shown you the delta of the deterministic PD. It is saying that one state by getting some input alphabet by seeing the top of the stack, some input alphabet, top of the stack, it is the top of the stack. It will go to some state and it can replace the top of the stack. It will always replace the one symbol that is in the top of the stack. Whatever will be in the top, let us assume it is having A, it will replace its top of the stack. Always it will replace the top of the stack with some symbol. Okay, some string, you can say some string, some symbol, that will be here tau star. So tau star is your stack alphabet. Okay, and what I have taught you that if Q A B, here for every state you need to give the transition for every input alphabet. Here for every state, for every input alphabet, you no need to give the transition. If you want, you can give. If you don't want, you can leave it. Okay. Another point I have given you, that one state, if you have given a null transition for some top of the stack, okay, for some top of the stack you have given the null transition, then for same this state and same top of the stack you can't give the transition for any other input alphabet. Means if Q by getting epsilon, you have went to some state, so Q by getting epsilon, by seeing the top of the stack B, it is replacing B with BBB. Then Q by seeing some other like C, and by seeing that same top of the stack, it will not go to any other state. This is not possible. If same state and same top of the stack, if you given in the If selen move, then for same state and same top of the stack, you can't give any other input alphabet transition. But if you will change the input alphabet, like I have changed the input alphabet, this is allowed because the input alphabet I have changed. So it's saying that for same state and for same top of the stack, if you have given a null transition, then for the same state and same top of the stack, you can't give any other transition. So if you want to give the transition, you change the top of the stack. Am I clear? So the language accepted by Pushdown Automata, deterministic Pushdown Automata, is called deterministic context free language. Then I have taught you that SPX, it means it will go to some state key and it will replace the top with Z80X in that order. Okay, so if S is a some state, if it is replacing, if we have seen the some input B and if the top of the stack is X, then it will replace the X with Z0 and X in that order. Means X will get replaced by first Z will get insert, then X, then state S will go to T. So first it will replace the top of the stack X with Z80 and X in that order only, then it will go to the state T. And then I have taught you acceptance, two types of acceptance. One is acceptance by final state, another acceptance by empty stack.